Hello everyone, in this video we'll be discussing probability of combined events, and the questions in this worksheet are from paper 2. Before you do this worksheet, you should be done with probability of single events. So in case you don't know that topic, there's a video of mine on that topic. You can go watch that first and then come watch probability of combined events. This is again paper 2 worksheet, and after this one we'll be doing paper 4 worksheet, which will have relatively more advanced questions on this topic. Okay, question number 1. The probability that it will rain on any day is 1 upon 5. That means from 5 days, probably it will rain 1 day out of 5 days. Calculate an estimate of the number of days it will rain in a month with 30 days. So if out of 5 days it's raining 1 day, then in 30 days, how many days can we expect the rain? So all we need to do is multiply the probability with the number of days. So we do 1 upon 5 times 30, which gives 6. So 6 is the answer for question number 1. Question number 2. The probability that a sweet made in a factory is wrong shape is 0.0028. One day the factory makes 25,000 sweets. Calculate the number of sweets that are expected to be wrong shape. So again, you multiply the probability with the total number of sweets, 25,000, which gives 70. So to find the expected number, you simply multiply the given number with the given probability. That's it. Similarly, in question number 3, I'm not even going to read the question. It is going to be 0.72 times 225, which will give 162, and that's 162. Okay, and then in question 4, a letter is chosen at random from the list. Find the probability that the letter chosen is A. So in part A, how many letters have A? That's 2 letters. And then how many letters are not? How many letters do we have in total? That's 1, 2, 3, 4, 5, 6, 7. So the answer is simply 2 upon 7. For probability, we do favorable outcomes over total number of outcomes. So number of favorable outcomes are 2 and total number of outcomes are 7. So the probability is 2 upon 7. A letter is chosen at random from the list and then replaced. This is done 63 times. Work out the number of times letter A is expected to come. So just like in the previous parts, you multiply 2 upon 7 with 63, which will give 18. Next question. 2 spinners have sections numbered from 1 to 5. Each is spun once and each number is equally likely. The possibility diagram is shown below. So the possibility diagram is showing that if we get 1 in the first spinner, in the next spinner we may get 1, 2, 3, 4, 5, and this lists all the combination. For example, when we get 4 in the first spinner and let's say 4 in the second spinner, this is represented by this region. So it's actually representing all the possibilities. Find the probability that both spinners show the same number. So that's going to be 1 and 1, 2 and 2, 3 and 3, 4 and 4, and 5 and 5. So the probability will be favorable outcomes, which is 5, divided by total number of outcomes. Total number of outcomes are 1, 2, 3, 4, 5. 5 times 5, 25. So 25 in the denominator. The sum of the numbers shown on the 2 spinners is 7. So where would we have a sum 7? 1 and 5, no. 2 and 5, yes, 7. 3 and 4, yes, 7. And 4 in the first spinner, 3 in the other spinner, 7. Again 5 and 2, 7. So 4 out of 25 times the sum of both the numbers on a spinner is going to be 7. Next question. The diagram shows a fair spinner. Anna spins it twice and adds the scores. Complete the table for the total scores. So again, this is showing a possibility diagram for score on the first spin and then score on the second spin. So if we get 1 and 1 on both spinners, the sum will be 2. Similarly, sum 4. Here sum is 4. So fill up the whole table. This will be 4 plus 1, 5. This will be 6 plus 1, 7. Let me just fill it up. So I've completed the table. Part B, write down the most likely total score. So what is the number that's occurring the most in the data? So let's see. I see lots of 6. So 1, 2, 3, 4, 4, 6. So it's just 4, 6. Then I see a lot of 7 as well. 1, 2, 3, 4, 5, 6. So I have 6, 7. So I believe that's the number occurring most of the time. So the answer is 7. Find the probability that Anna scores a total less than 7. So how many times do we have a total less than 7? So here it is, less than 7. Similarly, all of these, then this. So we have 1, 3, 3, 6, 9, 10. So 10 times the score is less than, oh, I have more numbers. I have a 7 or 5 over here, and I believe that's it. So 4, 5, 6, 7, 8, 9, 10, 11. 11 times the score is less than 7. Oh my bad, it had said less than 6, not less than 7. So these many times we get a number less than 7, which is 1, 2, 3, 4, 5, 6, 7. 7 times. So the probability is 7 divided by total number of spins, which is total number of turns in the denominator. Find the probability that Anna scores a total of 3. So how many times is Anna scoring 3? Actually, she never scores 3. So the probability will be 0. The probability that Pedro scores a goal in any match is 2 upon 5. Calculate the probability that Pedro scores a goal in each of the next 2 matches. So probability of scoring a goal in the first match will be 2 upon 5. Probability of scoring a goal again in the next match will be 2 upon 5. So when it says calculate the probability that Pedro scores a goal in each of the following next 2 matches, that means he's scoring a goal in the first match and he's scoring a goal in the second match. So and actually corresponds to multiplication. So the answer will be 4 upon 25. Okay, next question. Simon has 2 boxes of cards. In one box, each card has one shape drawn on it that is either a triangle or a square. In the other box, each card is colored either red or blue. Simon picks a card from each box at random. So we have 2 boxes. In one of the box, we have a triangle or squares, and in the second box we have either a card of red colored cards or blue color cards. So red color cards or let's say blue color cards. Okay, so the probability of picking a triangle card is T. So probability that we'll get a triangular card is T, which means probability that we'll get a square card would be 1 minus T, because the total probability is always 1. Sum of probability is always 1. Then probability of picking a red card is R. So probability of getting a red is R. Then that means probability of getting the blue color would be 1 minus R. Again, since the sum of the probability is 1. Okay. Complete the table for the cards that Simon picks, writing each probability in terms of R. So probability of getting a triangle and a red. So triangle is probability of getting a triangle is T, and means multiply. Red is probability of getting a red card is R. Okay, then triangle and blue. So T and 1 minus R. Then square, which is 1 minus T, and blue, which is 1 minus R. So that's how we fill up the table. The diagram shows 5 cards. 2 of the cards are taken at random without replacement. 1, 2, 3, 4, 5. Find the probability that both cards show an even number. So probability of getting an even number in the first attempt would be either if we get 2 or if we get 4. So probability would be 2 upon 1, 2, 3, 4, 5, the total 5 cards. And the question says without replacement. That means if we get one of these cards, either 2 or 1, we replace it. We put it outside, we do not put it back in the set. Which means the next time the total number of cards would be 1, would be 4, would be 1 less, which makes a 4, and now the total even numbers would be 1. Even numbered card would be 1 because we've already taken 1 out from the set. So the answer would be 2 upon 5 times 1 upon 4, which is 2 upon 20. Okay, next question. In this question, give all your answers as fraction. A box contains 3 red pencils, 2 blue pencils and 4 green pencils. I've shown that in the figure that I've made. Raj chooses 2 pencils at random without replacement. Calculate the probability that part A, they are both red. So probability that the first pencil would be red would be 3 upon how many pencils do we have in total? 4, 5, 6, 7, 8, 9. And then times probability of getting another red pencil. So if you get a red pencil, then the second time probability of getting a red pencil would be now 2 upon 8, because one of the red pens was already selected and it's outside now. It's placed outside. So then next time you don't count this. So the answer would be, let me just remove that mark. Yes, 2 upon 8, which gives 1 upon 12 rounded off answer. Okay, for part B, find the probability they are both the same color. So it's either going to be red and red like in the first case. So probability of red and then again getting another red. So probability of red and red, which we've already found by the way in the previous part, or probability of blue and then again blue and then get another blue, or probability of getting green and green. So we'll find all the probabilities. We already have probability of red and red, which is 1 upon 12. Then OR means add. Here also OR means add. Probability of getting a blue and then again a blue would be 2. We have 2 blue pencils, and then we have total 9 pencil times, if you've chosen a blue pencil, it comes out, and we assume now that we have only 1 blue pencil inside, and total we have 8 pencils inside. So 1 upon 8 times getting a green pencil and then again getting a green pencil. Probability of that would be, first time getting a green pencil would be 4 upon 12. Then one of the green pencils has been selected, it goes outside, so we're left with 3 green pencils inside, and it wasn't 4 upon 12, it was 4 upon 9 times 3 upon 8. This should give us the final answer. Okay, then part C says that find the probability that exactly one of the 2 pencils is green. That means we're finding the probability that, let's say, the first pencil is green and the other one is not green. So I'll put a slash on it. Or maybe the first one is not green and the other one is green. So instead of finding these 2 probability twice, what I can do is find one of these probability and multiply it with 2. So now 2 times probability of getting a green pencil is 4 upon 9 times, now that green pencil goes outside. So in total we have 8 pencils now. So one of the green pencils is outside, and then the other one should be not green. So how many not green pencils do we have? 3, 4, 5. So times 5. Find this product. Next question. Box contains 3 blue pens, 4 red pens and 8 green pens, like I have so neatly shown. A pen is chosen at random from the box. Find the probability that the pen is green. So one pen is being chosen. Simply probability that it being a green pen will be, we have 8 green pens divided by how many pens do we have in total? 8, 9, 10, 11, 12, 13, 14, 15. So 8 upon 15 is the answer for part A. Part B. Another box contains 7 black pens, 8 orange pens, 8 orange pens only. Alright. Okay, so here it is. 7 black pens and 8 orange pens only. 2 pens are chosen at random from this box without replacement. calculate the probability that at least one orange pen is chosen. So that means we can have two pens are being chosen. So one of them can be orange or both of them can be orange. So that means the only case that is not allowed is that both the pens cannot be black. One has to be orange. So we're finding probability of orange pen and then a black pen, or probability of black pen, this is and then an orange pen, or probability that both pens would be orange. So either we find all three of these probabilities and add them, or a better way to do this is find probability of 1 minus probability of black, because the only case that is not allowed here is that both the pens are black. That is not possible. So we can, instead of doing all those three probabilities above, I will just do 1 minus, what's the probability of getting the first black pen, that is 7 upon, how many numbers do we have in total? We have around 15 pens, and times, when we already have one black pen, one black pen goes outside, so now we're left with 6 black pens and total 14 pens. So this difference should give us the answer, which gives us 168 upon 210, or simplified answer 4 upon 5. Okay. Box A and box B each contain blue and green pens only. Raphael picks a pen at random from box A and Polo picks a pen at random from box B. Probability that Raphael picks a blue pen is 2 upon 3. So probability of getting a blue from this box is 2 upon 3, which actually means that probability of getting a red, what are we talking about, pen, is 1 upon 3. Since out of 3, 2 pens are blue, that means out of 3, 1 pen is red. Okay. Then it says the probability that Raphael and Polo pick a blue pen is 8 by 15. Okay, find the probability that Polo picks a blue pen. So we will use this statement over here. The probability that Raphael and Polo both pick a blue pen is 8 by 15. And means we'll be multiplying the probabilities. What's the probability of Raphael getting a blue pen? That is 2 upon 3. What's the probability of Polo getting a blue pen? That's x. And the answer is equals to 8 upon 15. So x will be equals to 8 upon 15 times 3 upon 2, which gives 4 upon 5, which means probability that probability that Polo picks a blue pen is 4 upon 5. So we know this, which means probability that Polo picks a red pen is 1 upon 5. Okay, find the probability that both Raphael and Polo pick a green pen. Okay, so one of the pen was blue and the other pen was green. I wrote red pen. I don't know why did I do that. Let me just quickly fix that. Okay, so part B, find the probability that both Raphael and Polo pick a green pen. So we simply multiply both the probabilities of getting a green pen. 1 by 3 times 1 by 5, which is 1 by 15, which is the answer for part B. Okay, next question. Samira and Sonia each have a bag containing 20 sweets. In each bag there are 5 red sweets, 6 green sweets and 9 yellow sweets. Part A, Samira chooses one sweet at random from her bag. Write down the probability that she chooses a yellow sweet. So how many yellow sweets we have? 9. How many sweets do we have in total? 20. So the answer for first one is 9 upon 20. Part B, Sonia chooses 2 sweets at random without replacement from her bag. She show that the probability that she chooses 2 green sweets is 3 by 38. Let's see, probability of choosing 2 green sweets means getting a green sweet first and then again getting a green sweet. So probability of getting the first green sweets would be 6 upon 20 times, when we get 1 green sweet we put it outside of the bag. So now in the next attempt we'll have 5 green sweets left inside and total 19 green sweets left. So this gives 30 upon 380. So we've shown the required number. Part, this was 1. Part 2, calculate the probability that the sweets he chooses are not both of the same color. That means it can be red green or green red or red yellow or yellow red or green yellow or yellow green. So I have multiple possibilities. Probability of getting red and then green, or probability of getting green and red, or probability of, in fact what I'll do, I'll write 2 over here. If I write 2 with this probability, that means I'm considering both the cases, probability of red and then green or green and then red. Similarly, there's a possibility of getting red and then yellow or yellow and then red, hence I've written 2 with it, and then 2 times probability green and yellow or yellow and green. So either we find these 3 probabilities, multiply each probability with 2 and get the answer, or what we can do is we're finding the probability that the sweets she chooses are not the same color. So that means we're doing 1 minus, we can't get a case probability of getting a red, we shouldn't get the case of yellow, and we shouldn't get the case of green, which means if first is green, the other can't be green. So either I do the first scenario or I'll do the second scenario. I think I'll just go with the second scenario because I already have this result, probability of green. So I already have this result. I will simply go with the second case. So 1 minus, what is the probability of red? Probability of red is 5 by 20 times 4 by 19. Then minus probability of yellow is 9 by 20 times 8 by 19, and then probability of green I already know is 30 by 380. So I'll find this difference and that should be the final answer, which gives me 258 upon 380, or rounded off answer 129 upon, sorry, not rounded off answer, simplified answer 129 upon 190. Next question, Haris is taking a driving test. Probability that he passes the driving test at the first attempt is 0.6. If he fails, probability that he passes at any further attempt is 0.75. Calculate the probability that Haris passes the test at the second attempt, which means he is failing in the first attempt and then passing in the second attempt. So we're finding the probability of, probability of failing and then passing. So what's the probability of failing? The probability of passing in the first attempt is 0.6, right? So the probability of failing in the first attempt would be 0.4. So the first number would be 0.4. He fails the first time, and which means multiply, then he passes the next time, which is times 0.75. This gives us 0.75 times 0.4 gives us 0.3. Okay, part B. Takes no more than 3 attempts to pass the test. So if he's taking no more than 3 attempts, means he can pass the first time or fail the first time and then pass again, which we've already found, by the way, whose probability we've already found, or fail and then pass. So either he passes in the first attempt, or he fails and then pass, or he fails and then pass, but he must pass it the third time. So now find all these probabilities. So the first probability is 0.6, or means plus. Probability of failing and then passing is already 0.3 from the last part, and then failing probability is 0.4. Again, failing probability is, if he fails, the probability that he passes in any further attempt is 0.75. So if he in the second attempt or in the third attempt or in the 50th attempt, the probability of passing is 0.75, then probability of failing would be 0.25. 1 minus 0.75. Okay, so now failing again would be 0.25, and then finally passing will be 0.75. So this whole product slash sum should give us the final answer. Okay, the answer will be 0.975. A group of 200 people were asked which city they would like to visit next. The table shows the results. A person from the group is chosen at random. Write down the probability that this person would like to visit either Paris or Tokyo next. So, how many people like to visit Paris? 48. How many people like to visit Tokyo? 46. So, total people wanting to visit either one of these countries is 48 plus 46, which makes 94. So 94 upon how many people do we have in total? 200. So 94 upon 200 is the answer for part A. Part B, 2 people are chosen at random from the group of 200. Find the probability that one person would like to visit London next and the other person would like to visit New York next. So probability of going to London next and the other person would like to visit New York next. Okay, let's read the question. 2 people are chosen at random from the group of 200. Okay, so find the probability that one person would like to visit London next. So let's see, one person wants to let's find the probability that one of the person chosen wants to visit London. So 50 people in total want to visit London, and we have a total of 200 people. Okay, so that's the probability that the person wants to visit London, and the other person, and means multiply, the other person would like to visit New York next. So the total people wanting to go to New York is 56, and now the total number of people left would be 199 because we have already chosen a person who wants to go to London. So total number of people are now 199, and then give your answer as a percentage. But before we find the percentage, we need to multiply this with 2. Why? Because we have 2 options, London and New York, or there is a case where the first person chosen wants to go to New York and the other person wants to go to London. So either we find both these probabilities separately, or we find it once and multiply it with 2, which I just did, and then whatever answer we get, we times it with 100% to get the answer as a percentage. So this whole thing in the calculator gives me 14.07035%. Rounding off to 3 significant figures gives 14.1%. Next question. Dan either walks or cycles to school. The probability that he cycles to school is 1 upon 3, which actually means that the probability that he walks to school is 2 upon 3. Remember, in a tree diagram, the sum of the probabilities on a branch, 2 connected branch or 3 connected branch or 4 connected branch would be 1. So sum of this should be 1. So 1 upon 3 plus 2 upon 3 is 1. Similarly, if this is 1 upon 8, then this would automatically be 7 upon 8. Similarly, if that's 3 upon 8, then this would automatically be 5 upon 8. Okay, let's read the rest of the question. Write down the probability that Dan walks to the school. So that's simply 2 upon 3, already done. When Dan cycles to school, the probability that he is late is 1 by 8. And when Dan walks to school, the probability that he is late is 3 upon 8. Okay, complete the tree diagram, done. Part C, calculate the probability that Dan cycles to school and is late. So he cycles to school and is late. And means multiply. So for C1, the answer is simply 1 by 3 times 1 by 8, which is 1 upon 24. Okay, C2 says Dan is not late. So I have to find the probability that Dan is not late. So it's either this case that he's cycling and he's not late. So that's going to be 1 upon 3 times 7 by 8, or means plus there's another case that he walks and he's not late, which is 2 upon 3 times 5 upon 8. So this product and sum would give us 17 upon 24. Okay, another question. Probability that the school bus is late is 9 upon 10. If the school bus is late, the probability that Seb travels on bus is 5 upon 16. If the school bus is on time, the probability that Seb travels on bus is 3 by 4. Find the probability that Seb travels on bus. So if we have two options. So either probability that he is late and then he travels on the bus, or probability that he is on time and then he travels on bus. So probability of being late is 9 upon 10 and means multiply probability of going on a bus is 15 upon 16, or means plus probability of being on time is, if his probability of being late is 9 upon 10, then probability of being on time is 1 upon 10 times probability of going on the bus is 3 upon 4. Let's see what we get. As this gives us 147 upon 160. The probability of a cricket team winning or losing in their first two matches is shown in the tree diagram. Find the probability that the cricket team wins at least one of the match. So we will consider the case of win and win, or win and lose, or lose and win, but not lose and lose, because the at least one of the match has to be won. So either you do the whole thing, either you do 1 by 3 times 3 by 4 plus 1 by 3 times 1 by 4 plus 2 by 3 times 3 by 4, which is actually, what is this? This is win and then win, or win and lose, or lose and then win. Either you do this, or what you do is, another option is 1 minus probability of losing and losing. So that's the case we don't want to take. Any other case we'll accept. So 1 minus probability of losing and then again losing is 2 by 3 times 1 by 4. So this should give 5 upon 6, and also all of these should also give 5 upon 6. So use either one of these methods.